Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In today's lecture, we will be focusing on linear function and composite functions. So let's start with linear function. When we talk about linear function, it means a straight line function. So let me pick up a equation. Let's say fx is equals to 2x plus 1. Now, what is the function of this function? It will take a value x, it will multiply by 2, and then a 1 will be added. So first multiply x by 2 and then add 1. So that is the function of this function. Now, if I draw a table of 3, 4 values, just to give you the idea. So let me write some values over here, x. Let me write f of x, the y value. Let me write -1. Let me write 0. Let me write 1. Let me write 2. Let's start with 0. 2 into 0 plus 1 is 1. 2 into 1 is 2 plus 1 is 3. 2 2s are 4. 4 plus 1 is 5. And -2 plus 1 is -1. These are the values. Now, if I draw a grid over here, and I want to plot these values, just a rough graph. So let me just draw it in red color. And something like this, the graph will be drawn a little bit more slanted. Now, if I focus on these values, and let me just pull this thing up a bit like this. So this particular value, and let me just shift it down. Okay. And can I? Okay, I think this is better. So now this point over here, this is 0, 1. So let me focus on this. So this point is 0, 1. That is one of the obvious point that I have plotted. And I'll be focusing on this. And this is y is equals to fx, that is the straight line. Now, there are different things that could be done over here. First thing, look at these values. We have these 4 points over here, -1, -1. This is 0 and 1. This is 1 and 3. And the other point is 2 and 5. So if I talk about f inverse x, what happened? We should have something which is reflection in line y is equals to x. Therefore, -1, -1 after flipping will remain as -1, -1. And let me just check one thing. 2 into -1, -2 plus 1, all good. 0, 1 will become 1, 0. 1, 3 will become 3, 1. 2, 5 will become 5, 2. Because a point such as AB will become what? Will become BA. Coordinates flip. So that is the first thing that needs to be done. Now, let me choose purple color for this. And let me draw a line something like this. It's not exact. It's just a rough diagram, something like this. So now this is y is equals to f inverse x. And also, we should draw this thing. That is the line y is equals to x. Because the reflection is in this line. So this is the line y is equals to x. Now, if I'm interested in finding this point of intersection, what are the different options that I have? I can solve fx and y is equals to x. I can solve y is equals to x and y is equals to f inverse x. I can solve the red and the purple line, which is the original and the inverse function. All good, all clear? So let me just check if everything is good. Yes, everything is good. So now the first thing that we need is that y is equals to fx and y is equals to x. We know that fx is 2x plus 1. We know that y is equals to x is the other line. So solve simultaneously. If I solve simultaneously, 2x plus 1 equals to x. Therefore, 2x minus x is equals to -1. Therefore, x is equals to -1. Since it lies on the line y is equals to x, therefore y is also -1. So therefore, point of intersection is -1, which coincidentally we already had it over here. This is -1 becomes remains as -1. So this is -1, this is -1. That is how this point is found. So that is the basic idea. What else can I find? I'm interested in finding the expression for f inverse, expression for inverse function. So we have this thing of writing let y is equals to fx. Therefore, f inverse y is equals to x. Y is equals to 2x plus 1. Y minus 1 is 2x. Y minus 1 divided by 2 is equals to x. What is x equals to? X is f inverse y. X is f inverse y. So we found the expression. It's just that we have a habit of writing everything in terms of x. So f inverse x is equals to x minus 1 over 2. That is the expression. Even if I solve this one with y is equals to x, I'll still get the same thing. So let me add a page. So y is equals to half bracket x minus 1. And y is equals to x. Let's double check. Let's solve it simultaneously. Half x minus 1 is equals to x. X minus 1 is equals to 2x. And then x minus 2x. Negative x is equals to +1. Therefore, x is -1. Therefore, y is -1. Therefore, the point of intersection is -1, -1. So these are some of the basic ideas regarding the straight line linear function. So just acknowledge it on the WhatsApp if this is all good, all clear. So now linear function is all done. So let me write over here that as linear function. And I think that's all good to go. So yeah. And then we can move over to composite function. Okay. So let me give the heading of composite function, one single video which has these two things together. So composite function is also an interesting idea. Composite function. And we can also say that this is function of a function. There are two things which are at work over here. So now let's get started with a basic function. Let me write fx is x plus 1. And let me write gx, which is x squared. What is the function of this function? It adds 1. What is the function of this function? It squares the value of x, squares the value. That is the function. Now let me choose a starting value. Let me write x is equals to 2. Let me first plug in fx. So f of 2, that is 2 plus 1, it makes it 3. Let me use this result in the gx function. So now gx, let me write over here, g of 3, that is 3 square, which comes out to be 9. That means an x value of 2 is becoming 3 and it's becoming 9. So 2 is becoming 3 by y is equals to fx because it adds 1. And 3 becomes 9 by the function y is equals to gx. All good? All clear? Now, what am I interested in? I am interested in a single function that will change 2 all the way to 9. That means this is my input and my output should be 9. That one single function is the composite function which I am looking for. Now, I don't know much about functions and I want to explore. I want to realize this idea, how to get this thing started. So let me again write over here, fx is x plus 1, gx is x squared. Let me evaluate f of gx. Let me evaluate g of fx. I don't know which is the correct one. I want to explore. We want to learn together. Now, when we evaluate f of gx, that means gx should go in place of x. And when we evaluate g of fx, that means fx should go in place of x in g. That is what it means. So f of gx is basically f of gx means gx in place of x plus 1. What is gx? That is x squared, and we are adding 1. Let me just use a bracket over here. So this comes out to be x squared plus 1. Similarly, what is g of fx? So g of fx is plugging fx in g. That is fx, the whole thing square. And this is x plus 1, the whole thing square. Just leave it as it is. So far, so good. Now, let me choose the starting value, which is 2 over here. And let me see which one is giving me 9. So if I evaluate f of g of 2, that is 2 square plus 1, it's giving me 5. If I evaluate g of f of 2, that is 2 plus 1 whole square, which is 3 square. And yes, that is giving me the right thing. That means order makes a difference. First f, then g. This is g of f of x, because first you are taking x, you are plugging in f, the result you are plugging in g. So first f, then g, that is g of fx. So now just acknowledge, have a good look at it, and just acknowledge if this is all good, all clear. Order makes a difference. And this is about composite function. Okay, so I'm just waiting for your reply. This is the first group, the second group, and the third group. So let me just pause the recording for a while. So now that the recording is resumed, just focus on this. We have 2, it becomes 3, 3 becomes 9, okay? And a single function that maps 2 onto 9, that is called a composite function. So let me rewrite this idea a little bit more. So we have 2, and this 2 is becoming 3, 3 is becoming 9. First function, that is y is equals to fx. So 2 is like the domain of f. 3 is like the range of f. Let me introduce another function. That is this one. That is y is equals to gx. And 3, the output of fx, becomes the domain of g. And the range of g is this thing, which is 9. All good, all clear? Now 2 is becoming 9. Now 2 is becoming 9. First f, then g, that is g of fx. So for the purple graph, I'm just writing x properly. For the purple graph, 2 is the input. For the purple function, 9 is the output. So 2, that is the domain of gf. 9, that is the range of gf. All good, all clear? Very important. And this thing we will be focusing a little bit further later on. The domain of f is also the domain of gf. The range of g, it's also the range of gf. And in order for this function to exist, and this is something that we'll focus much more deeper later on, the range of f should be less than or equal to. It should be a subset. I'm using this terminology. Range of f should be the same thing for right now as domain of g. If this is not the case, function GF composite will not exist. Again, have a good look. Y is equals to fx. This is the domain. This is the range. Gx, the range of f becomes the domain of G. And now this is the range of G. In order for function to exist, whatever comes out should go inside. Maybe completely, maybe a little bit lesser, but something else from outside cannot come. For the composite, the purple function, the domain of f is the same thing as domain of GF because that is the starting value. And the output of G is the same thing as output of GF. So that is the basic idea. Now let's do some questions from here. The functions G and F are defined by such and such. Fx, this is a straight line function. X is an element of real numbers. Gx, this is a reciprocal function. X is an element of real number. X should not equal to 1.5. Why? Because if 2x plus 3 equals to 0, if the denominator equals to 0, function is undefined. 2x is negative 3, x is negative 3 over 2. That is written over here. That means x could be any value except negative 1.5. Now over here, let's focus on this. Find the value of x for which f of g of x is equals to 3. Something very basic. So let's start with this first part, and let me also copy and paste it on the next page because I might be needing this thing. Okay, so first of all, f of gx, we need an expression. So f of g of x, first find the expression. That means gx will go inside x in place of x. So f of gx is equals to 3gx plus 2. That is 3 times, what is gx? That is 6 over 2x plus 3. This is 6 over 2x plus 3, close the bracket, plus 2. And just simplify it a bit. So this is 18 over 2x plus 3 plus 2. That is f of gx. Equate it to 3. So 18 over 2x plus 3 plus 2 equals to 3. 18 over 2x plus 3 is equals to 1. 18 is equals to 1 into 2x plus 3. 18 is 2x, 18 minus 3. Let me just write it first of all. So therefore, 18 minus 3 is 15 is equals to 2x. Therefore, x comes out to be 7.5. They're asking, find the value of x, a single value. That value is 7.5. So this is a basic type of a question. Let me do the second part. That is the graphical thing. Very easy. So now it says this thing, which is sketch in a single diagram the graph of y is equals to fx and y is equals to f inverse x. So let me draw a graph in red color. Let me draw a graph in blue color. Let me draw the line y is equals to x and as dotted in green color. So that is y is equals to x. And let's focus on this thing. So y is equals to 3x plus 2. Y is equals to, or fx is equals to 3x plus 2. Just use some values, x and fx. If I choose 0, I get a 2. If I choose 1, I get a 5. If I choose 2, 3 2s are 6. 6 plus 2 is 8. These are the 3 different values. And if I am interested in the expression for f inverse, that is coming later on, that I can do later on. But right now, what I can do is that I can just draw a grid. Hold for a second. So hold for a second. I'll just draw this grid. I can draw the line in green color. That is 45-degree angle because this is y is equals to x. And this is 3x plus 2. So red color I'm using. That is something like 3x plus 2. And the other one, the blue color thing, I think purple would be better. So let me just change this. Okay. And the other one should be like this. So this is just like the worked example that we did. So label everything. Y is equals to fx. Y is equals to x. Y is equals to f inverse x. Very obvious point is this thing 0, 2. So 0, 2 is very obvious. And this 0, 2 will become 2, 0. Label the x-axis, label the y-axis. What else is there to be labeled? Making clear the relationship between the two graphs. So that is by diagram, you have made it clear. That is the reflection. If you want to add a statement, that is perfectly fine. Y is equals to fx and y is equals to the inverse of f are reflection of each other in the line y is equals to x. So you have shown it, and if they're not asking for the point of intersection because it seems that they will be. So just show that value. You don't have to calculate, you just have to show this. Now, let me again copy this thing, paste it on the next page. And hold for a second. Yeah, a little bit up. Now, let me focus on the third part. Express F inverse and G inverse in terms of X. Let Y is equals to Fx. Therefore, F inverse Y is equals to X. Let Y is equals to Gx. Therefore, G inverse Y equals to X. Fx is 3x plus 2. Fx is 3x plus 2. So Y is equals to 3x plus 2. Therefore, y minus 2 over 3 is x, but x is f inverse y. X is f inverse y. Therefore, f inverse x is equals to x minus 2 over 3. All good, all clear? Over here, what is gx? 6 over 2x plus 3. Y is equals to 6 over 2x plus 3. Cross multiply the whole thing. So therefore, 2x plus 3 is equals to 6 over y. Yes, you can do it. You can cross multiply both things at once. No issue. 2x is equals to 6 over y minus 3. Therefore, x is half of 6 over y minus 3. If you want to simplify, you can. That is 3 over y minus 3 over 2. This is x, but what is x equals to? X is g inverse y. So x is g inverse y. And then we can write g inverse x is equals to 3 over x minus 3 over 2. Similarly, fx is this thing. They're asking us to equate these two. F inverse is equals to g inverse. So just equate the two. So the red one, x minus 2 over 3. X minus 2 over 3 equals to the blue one, 3 over x minus 3 over 2. Or we can write 3 minus x over 2. This is also good. Let me just double check my working. This is 6 divided by 2 is 3. And 3 over y, no. I think I made a small mistake. Let me just write it like this, which is better. Y oversimplify it. So this is half 6 over y minus 3. This is half 6 over x minus 3. I'll open it up later. So this is half 6 over x minus 3. All good, all clear? Now cross multiply. So 2 into x minus 2 is equals to 3 into 6 over x minus 3. So therefore 2x minus 4, this is 18 over x minus 9. Take 9 to the other side. 2x minus 4 plus 9 is 18 over x. And this is 2x plus 5 is equals to 18 over x. Therefore, 2x squared plus 5x is equals to 18. 2x squared plus 5x minus 18 is equals to 0. So 2 into 18 is 36. So 12 and 3, if I'm not mistaken. So this is 3 into 6 over x minus 3. Yeah, I think it looks all good. 9 fours are 36. So this is 2x squared. And this is minus 4x plus 9x minus 18 is equals to 0. 2x minus 2 plus 9x minus 2 equals to 0. So this is x minus 2. This is 2x plus 9 equals to 0. Therefore, x minus 2 equals to 0. X is positive 2. 2x plus 9 equals to 0, x is negative 9 over 2. So if the answers are given, they are not given over here. So I think it's pretty good. So that is the answer right over here. So that is the kind of question that comes. And this is about the basic idea of function, composite function, and inverse. So I think let's just stop the recording right over here. So that is enough for today. So this is, we have done linear function, we have done composite function, and that is the basic idea regarding these two. Take care, everyone. See you in the next class.